Hi everyone, this video is going to be the first part of a multi-part video series where I'm going to start out by showing a complete baking workflow for this turret, and that'll be using X-Normal and handplane. And then I'm going to move on to bringing the object into different game engines and then comparing handplane's output to 3ds Max normal maps, Maya normal maps, and X-Normal's tangent space normal maps. So to start off here, I'm going to talk about a few small things I did with this high poly model that will make the baking process a lot easier. So first off, you can see it's a fairly simple silhouette. There's relatively limited amounts of small concave shapes. And if I switch over to default lighting, you can see there's a few little wiry bits in here, but mostly this can be represented pretty easily by a low poly model. And that's important. Normal maps are obviously not magical. They have to be able to project it onto a low poly model. So you need to have the same silhouette in your low poly in order to accept the projection for the high poly model. Another thing worth pointing out on this model is that a lot of the edges have been left pretty soft. And that's in order to allow these details to make it through onto the normal map and then through the screen resolution to actually show up in game. So if you actually model your edges as sharp as they may be in real life, what can often happen is that there may only be 1 or 2 pixels in the normal map that actually represent that curvature of the edge corner. And then when the asset's rendered on screen, it either MIPs down and those disappear completely, or it just aliases really badly because there's not space to sort of let that edge breathe. And then the last thing I want to point out is related to the last idea, but it's slightly different, and that's details you want to project onto a surface, you want some amount of taper. And again, that's just to allow enough pixels to actually show the object. So an example of this would be these little hexagonal bolt heads. Obviously in real life these are not tapered like this, but if you look at it from a side view, it provides a couple pixels of space for this to show up. If it was perfectly 90 degree, there would be maybe 1 pixel faintly outlining the edge of this, and it would more or less be invisible on the model. So to sum up, when you're building your high poly model, the big concepts to hit are making sure that your silhouette is actually something you can represent with a low poly model, and making sure that things like your edges are chunky enough that they'll actually end up in the normal map and show up on screen at different distances. And then the taper is more or less the same thing, and just make sure there's enough information there that'll actually show up in game. Okay, so here's the low poly model, which is completed, and I'm just going to give it a quick once over to show you how this is set up. So this model does have some symmetry to it, and as a result I've deleted half for everything that's symmetrical, and that's so that I can share texture space easily and only have to UV one half of the model. So if I load up the UV editor, it has UVs and they're pretty simple. You can see that generally I've stitched stuff together wherever it's going to be convenient to paint. So for example, this side piece, this is all one shell, and the outer surface is one shell. And then in order to make my smoothing, I have a script through text tool called smoothing groups from UV shells, and this is super useful. And what it does is it adds hard edges at the borders between UV shells. So let me turn off ambient occlusion because that tends to break stuff. You can see like this is a separate shell for the front of this cylinder, so there's a smoothing split around it, and that's because these smoothing splits are free. And if you don't know what I'm talking about, you can refer to the controlling shading behavior video on the website, and that goes over in detail vertex splits and making efficient assets. And then I guess sort of the last thing with the UVs to look at is that I have padded them, so anywhere I do have a smoothing split, you can see there is padding in between, and again that's referenced in that controlling shading behavior video, but this is super important. So basically it's really simple UVs, there's some padding, and there are smoothing splits at the UV border edges. And the last thing I'm going to do before we get into sort of the projection related stuff is I'm going to triangulate this, and that's because I'm going to be sending this to a whole bunch of different engines, and I don't really know how they're all going to handle internal triangulation, and if a triangle gets flipped, it's going to create a shading error. So I just grabbed all the verts and connected them, and now this is triangulated. Okay, so I've got X-Normal loaded up, and I exported an FBX for my high poly model and for my low poly model. And I've got them both brought into the low definition meshes group and high definition meshes group. And what I'm going to do here is I'm going to make a custom cage for this model inside X-Normal. And the reason I have to do this is because X-Normal is quirky in that it splits projections along smoothing splits when you use just the standard baking ray distance settings. So to do that, I'm going to go into the 3D viewer, hit launch viewer, and it opens up this somewhat awkward model viewer. And you can see here are our two models, and they're overlapping and making all kinds of weird Z-fighting noise. So to make a custom cage, I'm going to go to Show Cage, this checkbox, and I'm going to say Global Cage Extrusion, and I'm going to zoom around and I'm just going to look if I've got this reasonably well encapsulated. And I so far do not see any areas that are going to be a problem, and you want to try to make it as generally as small as possible to limit projection issues, because we are doing this as one projection instead of as multiple. Okay, so that looks pretty good. And then in order to save this output, what I'm going to do is hit Save Meshes, and then I have my folder structure. And it's going to save an OVB mesh. This is like X-normal internal format. So I'm just going to call it turret low cage. And what this is actually going to have in it is the low and the cage in one file. And this question is going to pop up. It's going to ask, do you want to auto-assign the saved meshes into your mesh slots? I'm going to hit no. And the reason for this is it's going to also output, or attempt to output, a new copy of our high poly model for some reason. And if you hit yes, it'll reassign the path for the high poly model, and that's unnecessarily confusing. And then this is going to pop up, and it's saying that one of these models has more vertices than it's intended, and that's the high poly model. So in this case, it's asking if we want to skip. So I hit yes, I do want to skip exporting that. And it's going to do it for each of the sub-objects that pop up. And it says mesh is saved. So now I'm going to hit close. I'm going to go back into my low definition meshes. You can see it hasn't changed what's assigned here, so I'm going to say clear all meshes, add meshes, and then turret cage low OVB. This is the file I want. Select this. Make sure that you have use cage checked. And now this is set up correctly so it'll bake with this cage. If you don't know what I'm talking about with splitting projections, there's a good thread on Polycount about it. And generally you can think of it as, instead of the cage expanding as a whole group, it expands the surfaces outwards, or it looks outwards at totally separate directions, which will end up creating serious artifacts in your model. One of the nice things about handplane is that you can skip that whole cage making process and still get an average projection, because what you can do is you can tell it, instead of using the exported normals, you can tell it to average the normals, which is going to smooth your whole low poly model, and as a result project an average projection. But because handplane only has to output into object space, you don't actually need the smoothing of the low poly to be correct. So that's a huge time saver with handplane and X-normal and something I normally do. But in this case, because I also want to get a matching X-normal tangent space map out, I can't actually use that functionality. So now I'm just going to add a normal map. Let's see if I've got it set to 4x anti-aliasing. And I'm going to add some basic ambient occlusion. And from there, I'm just going to hit Generate Maps. And I'll pause this, and when the maps are done, I'll resume the video. Okay, so the bake is done, and I outputted an object space map, an ambient occlusion, and an X-normal tangent space map. So now I'm just going to make the other normal maps with handplane, but before I do that, I wanted to point out quickly that if you're using mirrored geometry, it's important that you use the same copy of the mirrored object for your object space map as you use to make your tangent space map with handplane. So, for example, this side pod. If I had flipped this over and used the opposite side when I make the tangent space map, I'd get inverted normals, because this outer surface still points the same direction in the world, even though it's been flipped, because that's how object space normals work. And this shouldn't come up in most workflows, and in this case, the easy way around having to deal with it is just to use the same low poly model in handplane as I used to bake. So I'm going to load up handplane. I've got that low poly model assigned. I've got the object space normal map assigned. It's set to auto detect, and I'm just going to start putting out an output for each of these. So there's 3ds Max. I'll do Maya 2012, and I'm going to add a 2012 to the suffix. And do one for 2013. And if you remember, the difference between these is just how the normals are weighted, but we'll do one of each. Unreal, and Unity and Source. And I'm not going to worry about the other two outputs. So you can see that was really quick. We've got all of our neural maps made. And now from here I can break and switch into each different game engine and we can compare the results.